Hello and welcome back to the lab. I'd like to take a quick moment and say thank you to all the people who have joined us in the lab and continue to join us, and I'd also like to say thank you to all the Patreons that have helped me with making decisions and also supporting the channel and helping me continue to make content for everyone to enjoy. It's been a wild ride and continues to be. I don't know about everyone out there, but I'm having a ton of fun, and we will continue to see where this goes. I've got some more ideas for videos in the future, but your questions and suggestions and everything do help give me ideas for videos, and it also lets me know what you guys would like to see, what everyone would like to see. So definitely keep those coming. They are a great help. This particular video, I've gotten a lot of questions about doing the scope calibrations and things like that. Lots and lots of questions about how to do a scope calibration if you don't have these three plugins. So that we restored in the last couple of videos, the SG503, the TG501, and the PG506. So if you want to try to tackle a scope calibration without these plugins, in this video I'm going to try to convey what makes these plugins special and the parameters of the waveforms that are important for doing the scope calibrations. With that being said, let me get this turned on. Since we're not doing a calibration, I don't have to wait for it to warm up. And we can get started. So to get started, we're going to need a 50 ohm terminator because the SG503 needs to be terminated in 50 ohms. And we have the special cable, which is the 1% precision coax cable. Of note on the cable is these ends are special proprietary ends. Most 50 ohm BNC ends are 52 ohm. These are 51 ohm to a high tolerance. That allows the leveling of the SG503 to be accurate and calibrated. Without the precision cable, you'll still get a waveform, sine wave, out of the SG503. You're just not sure about its particular output. So if you set this to 1.5 volts, are you getting 1.5 volts peak to peak on the output? Without this cable, you're not guaranteed that. Does it, cosmically speaking, matter? Depends on what you're doing for the calibration. If it says 4 divisions of display, no, you just adjust this to 4 divisions of display and it's no big deal. So if we hook it up, let's see. Yeah, 1.5 volts. We are at 1.5 volts peak to peak. So should be, since we just calibrated it. But what makes the leveled sine wave generator special is as you crank up the frequency. So right now we're at, actually a good example. So if I go down to 50 kilohertz, we have 8 divisions of display. If I crank the signal up without bumping the output control, we will eventually see there it goes, a reduction in signal. Now, that reduction in signal is not a reduction in the amplitude coming out of here. It's a bandwidth limitation of the front end of this scope. This scope's only rated to 100 megahertz. We're putting 262 megahertz into the front end of this scope. Now the scope's doing admirably for being twice its rated bandwidth. It's doing a great job. But that's the thing, is with it being a leveled sine wave generator, as you adjust the frequency, the amplitude doesn't change. So during a scope calibration, does that matter? For the most part, no. The only place that actually matters is when you're doing the bandwidth checks, and you need to know that this signal, the amplitude, doesn't change as you crank the frequency up. Anywhere it says sine wave generator to X divisions of display, you can use any sine wave generator for that as long as it hits the frequency response. I could use the SG501 for that at 50 kilohertz. It's when you have to do a frequency comparison where it says set it at 50, check it at 10 or 15. Now you need to have a leveled sine wave generator, and you need to be sure that the waveform or the amplitude isn't changing with respect to frequency. Could a modern arbitrary waveform generator be used for that? Very possibly. I actually haven't done the bandwidth checks on those, so I can't answer that for sure. I'm sure I'll do that eventually. I'd love to get a modern ARB for the lab. Coming on the shorter list of purchases for the lab, I needed to, in fixing these 3 plugins, I had to push the lab past the gigahertz mark, and in wanting to do a calibration on the 284, I have to push the lab even faster. I've got the 11801 down in the corner, which is good up to 50 gigahertz, but I have none of the sampling plugins. I don't have any of the SDs for the modules yet, so kind of stuck. So the fastest the lab goes is the DSA 602. Could an ARB be used to calibrate a scope? Absolutely, as long as the bandwidth works. You wouldn't be able to do the high frequency compensation because the arbitrary waveform generator may not be fast enough, and depending on the specifications of the arbitrary waveform generator, you may not be able to replace the PG506 with that one. The PG506 is a pretty accurate plugin, so you'd need to look at the overall accuracy of the ARB and make sure it would match the accuracy or better of the 506. Also remember, anything in the 700 series, 7000 series, 5000 series, 400 series, and even older back into the 500 series, the 400 series and the 7000 series and the 5000 series are 3%. I don't know what the specification percentage is for the 500s. I'm going to guess 3, but I don't have any of them, so I haven't looked at their data sheets in a while. The tolerances of the calibrators have to be tighter than the scope, and the tighter they are, the better. So I believe, if I remember the spec sheet right, the PG506 is 0.1%, and I believe the leveled sine wave generator, the level specification is 1% peak to peak. So as you ratchet this up, you will have a 1% error from what the readout is. And this is just the attenuator on the leveled sine wave generator. So on the SG503, its trick is the amplitude does not change with respect to frequency as you dial it up. There's another unit that pushes you faster than this. This goes up to 250 megahertz officially. Mine is running a little hotter than that, not much. But the SG504 goes up to 1.04 gigahertz. So 1 gigahertz plus 40 megahertz is where that tops out. Now that does the leveling differently. The SG504 has a power and a coax line that goes to a leveling head that you plug into the scope. That's how it does the leveling at the output. So where this was just a coax line, the SG504 has some circuitry up here that needs to be used. So if you're looking for SG504s on the internet and popular auction sites, things like that, and you see them, if they don't have the leveling head with them, they're not ready to go. There's an additional piece that you're going to need. Now the good news is that piece is available. There's a gentleman, where he is in the world, it currently escapes me, but he has rebuilt and made a better leveling head than what came from Tech. So he's actually increased the accuracy of the SG504 to better than factory spec. Now my SG504 will need to spend some time on this mat. It's got a problem where the low range is working, which is good because when I do I have a video that I have planned going through a 485. I also have a video that I have planned going through another 465, not the full calibration, but a repair, and really getting that ready for a for someone, so I can get that going. So the SG504 will come in handy, but it's on mine. The high range is dead. So the low range works, which is up to 500 megahertz. High range, it's out to lunch, doesn't work at all. So it's something I have to work on. Amplitude stays constant with respect to frequency. Other than that, it's a sine wave generator that's dialable. You set your peak-to-peak voltage, you set your frequency. This is the variable frequency knob. And as you can see, as I crank this back down, there's our 8 divisions of display. If I crank it up, the display collapses because of the bandwidth limitations of the scope, not the sine wave generator. Next on the list is the TG501, which I just got done restoring. I always plug that in the wrong one. What this does is it generates a very accurate horizontal time base. So if I roll this out, now we're on 10 microsecond pulses, scopes on 10 nanoseconds per division. So we have a pulse, a rise time pulse of less than 10 nanoseconds. So it's a very accurate period of a very sharp rise time pulse to allow you to align the horizontal of the scope. Really all it does, it makes time marks. Now what's one of the neat things about the TG is you can dial an error. So if you're checking a scope, like you get a new scope for the lab and you have no idea if the time base even needs to be adjusted, if it's far off or not, you can set up the different time bases, and then you can use the variable knob and the positioning control on the scope to line up the pulses, and that'll tell you the error. It'll calculate the error of the horizontal sweep. It was also a very precise way to measure pulses back before frequency counters, things like that. You could use this. I could stretch this out, and I could overlay a sine wave on top of this, and then I could measure the period of the sine wave, and then it would give me, because this is a very accurate time, very accurate pulses in time, I could use it to measure if I needed a more accurate than the time base of the scope. I could use this instead of the scope time base and actually take a measurement on a waveform. Fortunately, we've moved beyond those days, and we have things like a DSA and a Rigel. The Rigel, I can push measure, and it will give me every parameter of the waveform that I could possibly want. Nowadays, if I need to measure a waveform, definitely the digital scopes are the way to go. However, I do like using the analog scopes as well, so might do some of that later. Have to see what the mood strikes me. So if you were going to substitute a TG501, you would need a pulse, not necessarily a pulse generator, but some way to generate a very sharp rising edge with a very accurate time. Having just done the calibration on the TG501, the accuracy of that is 0.1% to period. So a sharp rising edge at a very accurate time base. Now, could that be done with an ARB? Probably. There are very fancy calibrators from Fluke that cost many tens of thousands of dollars that can do everything 6 gigahertz, DC to 6 gigahertz. So Sure. If I had one of those, I wouldn't need to. I wouldn't need the 501, but I don't have one of those yet. Probably won't for a while. If I ever need one, I don't even know if I'm going to need one. And then with those, typically what's done is a program's written. You go through the cal document of the scope, program's written, and it literally just steps through the process, and then you adjust the correct control for whatever the waveform is. Hit next, it goes to the next step. Adjust the control, whatever the waveform is, next, and you just step through the process. At the end of the day, the scope's done. Next calibrator, which is the hardest one to duplicate and probably the most important. These two are pretty easy. A frequency counter and a oscillator can get you there. This is just a leveled sine wave generator. Anything that has a good stable output, easy enough to do. The PG506, if you're going to go after one, that's probably the one to go for. Huh, my Rigol may be off. I may have to run an ACAL on it. Yep, the Rigol's off. Let me just check this, make sure nothing's happened to the... Huh. Perfect example of why the PG506 is important. Let me move over to the 7603. Okay, here we are at the 7603. And as we can see, I have the same 10... No, the calibrator's off. Because this scope is agreeing with the Rigol. So what happened to the PG506? Why is it off? Okay, sorry about that. I had a moment of panic there because I hooked the PG506 and I was going to say, the important part of it is a very calibrated amplitude square wave coming out, so you can adjust scopes to the PG506. And my Rigol said that it was 800 millivolts low on the 10 volt range, which is out of the specs for the Rigol. The Rigol's 4% accurate, so actually my analog scopes are more accurate than my digital scope. Who'd have thought? So 4% accurate DC accuracy, 3% accuracy on the 7000 series. So cool. Turns out I hadn't run ACAL on the Rigol in a while. If you haven't done that before, or the temperature has changed significantly from the last time you did that, it is utility. First off, you take all the signals out of the unit, utility menu, and you go down to self-cal, and you just run the self-cal routine. It takes about 30 minutes, but you don't need to hook anything up. It just does it itself. After running the self-cal routine, V peak to peak, 10.0. So I also checked that against my 7603. Turned out one of my 7A15 plugins was out, needed to be adjusted. The other one agreed, and the DSA 602 agreed. I am very likely to believe the 602 and the Rigol after ACAL, as opposed to the 7A15. The gain adjustment on those is very easy. It's just done on the front panel, so you can do it at any time. So 10 volt peak to peak waveform, but if I kick it down to 5, single shot capture, 5 volt peak to peak. One other thing to notice is when the scope's doing measurements, I have 5 volt peak to peak here when I have it as one division. Looks good. If I turn the measurement off and we raise it up, if we go to measure all, it's running a little bit low. Again, 4% is the just a little bit low. So I ran another single shot, now we're at 5. So if I could leave it running, it'd probably bounce between the two. Just beware, sometimes even the automatic measurements can get things a little shaky. We can kick it down to 2, bounce this up to, and as it averages in, I have 512 averages turned on to kind of get rid of the noise. So as the averages come in, it's going to clean up on the waveform. So there's some noise. So the PG506 for the vertical alignment has a calibrated, I believe it's 0.1% step for you to adjust the gain against. One of the other things that's a little weird about this is as you dial up the amplitude on the standard, the amplitude dives negative. That's the adjustment. So this reference is always stable. As I turn up the amplitude, the waveform does get bigger, but it dives negative. Little interesting. That's not the important part. This is just, so the high amplitude is just an adjustable square wave. That's all it is. Same thing that's in the Type 106. Sometimes I'll switch to my Type 106 from the PG506. The reason for it is this is not a PG506A. This is just a PG506. So this guy tops out at about 64 volts peak to peak. The PG506A completely replaces the 106, goes to a 100-volt square wave, so it'll drive the tunnel diodes and things like that. My particular PG506 does not have enough horsepower to drive my calibration fixture, so I need the larger waveform on the 506. So this high amplitude setting is exactly the same as a 506, along with the fast rise, fast fall outputs on the 506, or on the 106. So this bottom half of this instrument essentially duplicates a Type 106. So if you have a PG506, especially a PG506A, you do not need a 106. I like my 106. I enjoy it. I use it in a lot of my calibrations. You can do that with just this. You don't need both. The calibration generator that I restored in a previous video, that's the step amplitude version of the 506. Or for the 106. So that was a very confusing explanation. Let me go get the calibration generator. It'll make a lot more sense. The Leaning Tower of Test Gear. The blah, the 67502-1 or -0. This gives you the top half of a 506. The calibration generators with some other features, you can chop a voltage in and out, but this gives you the calibrated amplitudes to send out to the scope, so you can do the calibration. Also the 5 milliamp square wave, which is duplicated down here. So this unit plus a Type 106 combined make a PG506. That's what the two units do. So depending on where the switch is, you get the fast rise, you get the fast fall, you do get some triggering out, which the 506 has the 106 has as well. You also get the calibrated steps of the calibration fixture in here. So if you have these three units replace this unit, the 106, the 184, and the 191. All of those units get smushed into these three modules. There's a ton of stuff that gets smushed into these. I find this to be incredibly valuable. The calibration generator, things like that. Now, for most of the low frequency tuning and things like that, you do it with a square wave. So a lot of the tuning that gets done, we do it with a square wave. So gain set by the calibrated steps. I find that to be very important, very valuable. The other thing that's very valuable is this is a moderately fast edge, not really. 300 nanoseconds, moderately fast. But it's a fast rise with a nice clean top. There's no ringing. There's no nothing. If we zoom in here, we come up and we level. So Why is that important? Because when we're doing the frequency compensation of the vertical amplifiers, it's important that this comes up and then settles without any ringing or anything like that, because without any ringing or anything like that coming down the waveform, because that's what we're tuning. Reasonably fast up and a flat top is necessary. Any good square wave generator can do that as long as it doesn't have a ton of ringing and overshoot. So is that critically important? Not really. The Type 106 is just a square wave generator that's very variable. Jeez, can't talk. That's very variable. Any good square wave generator can do that, especially when you're tuning the amplifiers, if you're adjusting them and dialing them in. As long as you know that the square wave is clean, that's the important part. It comes up, stops, doesn't overshoot, doesn't undershoot, because that's what we're tuning out of the verticals. When we do the high frequency compensation of the vertical amplifiers, that is when the rise time starts to matter. So the plugins you see here, these three, this is everything you need to do 100 megahertz and under. You could do a 465 with these and get it perfect, get it in spec, and be done. If you want to kick it up to a faster scope, go above 100 megahertz, things get a little weird. So one of the things we're going to have to do is, well, that kicks us into the range of tunnel diode pulsars and things like that, but only for the high frequency compensation of the amplifiers. Everything else is done with these three plugins. The high frequency compensation, except for the bandwidth check. So bandwidth check needs the SG506. So we're through a 465B. Want to do a 485. We'll just go up to the 350 megahertz and have some fun. I also need, in addition to this equipment, I also need an SG504 or high frequency sine wave generator that's leveled or equivalent. The other thing is, because the the 45 does 350 megahertz in 50 ohm, to 200 megahertz in 1 meg, 350 and 50. The other thing we need is these rise times, these 1 nanosecond rise and fall times down here. These are no longer sufficient. We need faster rise times to do the high frequency compensation in the vertical amplifier. Everything else is done here. Calibrating a scope does not need a ton of gear until you need to go fast. So if you're looking at a 5000 series, that's 10 megahertz, 50 megahertz, 75 megahertz, this is fine. 465, this is fine. Anything under a 465, this is fine. 500 series, this is great. Kick it up to the 485, some of the 7000s, where we're starting to get into the faster plugins, 200 megahertz for the 7826s, the 7819 at 500 megahertz. Got to go faster. Now we need the tunnel diode pulsar and the high frequency leveled sine wave generator. Some keys to accuracy on these. On the SG503, one of the keys to accuracy is this peak-to-peak detector, which you guys saw me use at the end of the SG503 video. This allows the meter to say, yes, the leveling is happening. That's the important part. So this is its basis of accuracy, is this unit right here. The TG501's accuracy is its built-in crystal, which is tuned to something. Now the question is, what's that something? In my case, in the videos previous, we've tuned this to my GPS disciplined oscillator, which is picking up its accuracy from the GPS satellites in orbit, which are on a rubidium standard, which are also based back to cesium at NIST. For 3% on the horizontal, I got a pretty good standard for this in the lab. And the GPS DOs, my frequency counter has the ovenized crystal, but I don't know if it's tuned. I got my frequency counter off of a auction website, used secondhand. It's never seen a Cal lab. So I needed a basis of accuracy that I could trust to adjust this gear to. So that is my frequency and time basis so far in the lab, is the GPS DO. and my GPS DOs, because I have the Samsung one, which I did in a previous video. I also have Leo's that is inside. Its antenna, so the Samsung has an external antenna outside. Leo's has an antenna inside. These are just the conditions of the testing. Those two oscillators agree within 500 microseconds of each other. And that's where I got the time reference for this, for the TG501. To get this as accurate as possible, this is calibrated at DC. There's a switch in here as seen in the previous video. We flip that, we go to DC. This is calibrated DC. So the DMM 7510, which is the most accurate meter I have in the lab, that's where this one's getting its accuracy from. Now the fast rise and fall times, 1 nanosecond will give you just about to calibrate a 100 megahertz oscilloscope, 1 nanosecond's plenty. These were validated on the DSA, on the DSA 602, the sampling scope. We have the DC accuracy from the Keithley, which is undercal, bought brand new, undercal, and I'll be sending it out for cal when it's due up in, I think, February. So we have DC accuracy on here, and then that switch just flips the oscillator on and allows it to generate the square wave again. We have GPS DO accuracy here, and then we have, again, meter accuracy here. In terms of tying these all back together, especially since all of these were rebuilt here, I now trust these. I could send them off to trust them, or I could do it myself. It ended up being, even with having to buy a 7510, if your goal is as accurate as possible, doing them in-house was more cost-effective in the long run, especially with how many 7000 series plugins I have, the fact that I'm doing 4 of the portable scopes. It made sense for me to do this. If you have a 400 series scope, or a 465, I did get a quote from Tech. They quoted me, and this was before I had YouTube, so it's not like I was a YouTuber that was asking them. They quoted me just over $100 to calibrate a 465 and align it. I don't know exactly what that all entailed. If they'd tell you, yeah, it was in spec, no, it wasn't in spec, I don't know if that included adjustment or not. I don't know. I didn't have them do it. I asked what a 7603 was going to be. Now, these prices are also about 3 years old. I asked what a 7603 was going to be, $850. So it was going to be close to $1,000 to align a 7603. That doesn't even get us to a 7854 or a 7704 or a 7904 or any of the faster scopes. So just the 7603, they wanted $800 for it. It was a ton of work. You guys have been here for most of the ride as I've been going through and calibrating all this equipment, or aligning all of this equipment, I should say. But these were done prior to me starting YouTube. So I went through all these once before I started YouTube. I used the base accuracy of the 6500. So, because it was in cal at that point and everything was working. These were checked as I brought them into the lab before I started doing all the calibrations. They were checked again for videos, and because it was time, I needed to check them again. And they were all pretty close. Like, I don't expect them to drift much at this point due to the fact that their age and things like that, all the components, at this point, they should be pretty close to being done drifting. And as we know, the 506 needed work. But yeah, that's the plan going forward. And hopefully I demystified these 3 units, so when I'm off camera adjusting things where the scope is, I'm working the knobs on these 3 units. So primarily this is what I use for the scope cal. This plus the Type 106. I haven't had the 184 on. That's the other thing is the TG501 warms up in 30 minutes. The Type 184 warms up in 4.5 hours. It's 2 hours to heat soak the crystal, and so it's a long warm up time for that. Especially because I keep it off, because when no one's in the lab. I don't want any problems. That is still getting really warm in there. It's less so than it was before. The capacitors definitely made a difference, but the front of these are getting kind of toasty. I'm going to keep them in my 5000 bay just because so they have active cooling, keep them healthy. Redoing the capacitors has cooled it off, so it was definitely stressed. If you do acquire a PG506, be really careful with it. There is a 100-volt switching supply in here to generate the 100 volts from the voltages that are in the 500 frames. That transformer, if that transformer gets damaged or overheated or melted, it's going to be unobtainium to find it. It's going to be a very difficult part to source and find. Definitely check the capacitors in there, especially the bulk caps. If there's a problem there, that transformer is going to get stressed. So definitely check that out if you end up with one. Also, be careful if you open one. There's 100 volts in there. Thanks for stopping by the lab today. Sorry about the rambly video. I hope that helps demystify these 3 units and what's important about these 3 units to help everyone make decisions on what's a good substitution if you don't have one available. Definitely, if there's any questions, if I missed anything, let me know in the comments. I will definitely see everybody in the comments. And if there's any questions, feel free to reach out. I'll see what I can get answered for you. Thanks a lot, and I will see you in the next video.